All right. Find the electric field at point P. Draw the electric field vector, label its magnitude and direction, right? Charge A is negative 1.8 microcoulombs, B is positive 2.6 microcoulombs. Each grid line is a meter. All right. Okay, so the first thing to do, your first step, and the first step is the most important step, is to figure out which way these electric fields will be. Okay, so due to A, remember the electric fields are toward negative, right? Away from positive. Okay, this is the key thing because so many people just mess up the first step, and then it's so sad because you can do so much work. If you mess up the first step, it's just all over. Okay, so the electric field due to A is actually toward A. Okay, so here's our electric field due to A. The electric field due to B, though, is away from B. It's like that. Okay. Okay, so electric field of B is actually at 45 degrees. The electric field of A is here somewhere before 180 degrees. Okay, so the first thing to do is to just figure out the magnitudes of these, right? And our formula is that the electric field is K Q over R squared. You must memorize this, okay? It's not in your data packet. Now, the formula for gravitational field is there, and if you can just sort of do the analogy, there it is, okay? So let's find the electric field of A, the magnitude of it, right? The magnitude is 8.99 E9. Oh, hi, baby. My dog just came to join me here. Okay, and then let's see, A is 1.8 E minus 6, and then I'm going to divide by, oh dear, let's see, electric field. So A is, let's say we're 1, 2, 3 this way and 1 that way, right? So it's the square root of 1 squared plus 3 squared, right? And then remember that's our distance, and then that's squared. So the square root of ultimately, and this thing goes away because we square a square root, right? But I just thought I'd write that. So the R is the square root of, what is it, 1 squared plus 1, 2, 1, 2, 3 squared, right? Okay, so let's figure this out. 8.99 E9 times 1.8 E minus 6 divided by parentheses 1 squared plus 3 squared. This would be the square root of 10, I do believe, but there it is. Okay, so 1618.2. Okay, that was a good year. All right, and that is newtons per coulomb, right? And then let's figure out the angle of this thing, right? So let's just see. Okay, so I'm going to make a little triangle here. Right? And this angle right here, because it's it's going to be 180 degrees minus that angle, because this is 180 degrees here. Okay, so our angle is 180 degrees minus inverse tan of opposite, which is 1, over adjacent, which is 3. Okay, so 180 minus inverse tan of 1 divided by 3 is 161.57, I'll say. Okay, this kind of makes sense, right? Because if this is 180 degrees, 161 would be kind of in that direction, right? All right, so let's find the electric field of B. Okay, that's going to be, got to keep this all separated. All right, that is 8.99 E9 times, let's see, B is 2.6. Notice that I did not put the minus sign in there because that would confuse me to have like a negative number here, right? The fact that it's negative is encapsulated in the fact that I know that it's toward that thing and that it's at this angle, okay? I don't put the minus signs in generally, but if you were like uber smart and had some like ultimate understanding of this whole thing, right? There's some way we could deal with that minus sign, but I don't know, I'm not smart enough. Okay, so here we go. So let's see. B is 1, 2, 3, and 1, 2, 3, right? So it's going to be divided by 3 squared plus 3 squared. Okay. Isn't that right? 1, 2, 3, and 1, 2, 3. It's so bad to mess this up too. Okay, here we go. So 8.99 E9 times 2.6 E minus 6 divided by parenthesis 3 squared plus 3 squared. All right, here we go. And this is 1298 point, a lot of fives. Okay, and then, serendipitously, if you look at this angle here, that's got to be 45 degrees, right? Because we're 3 over 3 up, so that is at 45 degrees. Now, a little bonus for you, okay? Look for it, okay? I believe every single assessment is going to have one angle that's evidently obvious and is a 45 degree, or it's over here, so it's 135 degrees, or it's down here, so it's 225, is that what it is? Right, so look for those 45 degrees. I put those in there to make it a little bit easier, because these things are kind of hard to do. All right, so here we go. So now we've got to set up our little thing to add this thing up, right? So we're going to go EA, EB, right? Oh, it's so nice to be able to draw straight lines. All right. Okay, so let's see our magnitude, our angle, x component, our y component. All right, here we go. Okay, so the magnitude A is 1618.2. Its angle is 161.57. Okay, this guy is 1298.6. Its angle is 45 degrees. Okay, and now I'm just going to bust this out. Remember, this times cos this is this, right? So 1618.2 times cos 161.57. Right, and this will be, by the way, a negative number. We're going to have a number that's going to be to the left. So that's negative 1535.2. 1535.2 newtons per coulomb, right? So a lot of it's to the left, right? Okay, let's just double check. Did I type the right thing? Yeah, I did. Okay, so now I'm going to go second entry and change my cos to a sine, and that will give me the y component, which should be a positive number, 511.6. I'm just kind of rounding a little bit here, okay? But I have 4 digits and we have 3 sig figs, so I should be good. All right, so this makes sense, right? I've got a little bit of y, a whole lot of x. The x is negative. This makes sense. Okay, b should give me 2 positive components, so 1298.6 times cos of 45. 918.2 newtons per coulomb, and then I know that if I change this to sine, I'll get exactly the same thing, but I'm going to do it. I'm going to go second entry, go back, change my cos to a sine, 1298, yeah, okay, 918.2. All right, now we're ready for the fun stuff, right? Okay. Oh, these are newtons per coulomb too. Okay, so now we're going to figure out what EA plus EB is, right? So negative 1535.2 plus 918.2 is negative 617. All right, and then this guy is 511 plus 918.2 is 1429.8. I guess this is 0.0, right? Okay. Okay, there we go. All right, so it's to the left and it's up a lot. So let's draw a picture of that guy. Left. Up. So this is what you got to do. You got to draw me a picture. It's to the left, it's up. Draw me a picture of it, okay? This is 617. This is 1429.8. Okay. Obviously, we got to find the magnitude, right? So the magnitude is the square root of, ooh, good straight line there, of 617 squared. Do not put your minus sign in there. Absolutely do not put it in there, okay? Just ignore the minus sign. You know that a negative number squared is positive, unless you have a TI calculator, okay? And then negative numbers squared are, why, strangely negative. Okay, so just don't put it in there. Or if you do, put parentheses, negative something, and square it outside the parentheses, if you insist. Okay, so let's figure out this magnitude. The square root of 617 squared plus 1429.8 squared, right parenthesis. That's 1557. Ooh. Ooh, this is so good. It's so nice to get to the end of a, I don't know, 20-minute video and get the right answer, right? Okay, so this answer is 1557.2. Okay, and now let's find, I'm going to find this angle. I always just find the angle with the x-axis. You could find either angle, but what you need to do is make a drawing of this. Make sure that your vector is an arrow, that I know which way it's going, and you got to find an angle. Right? So I'm going to say this angle right there, right? That guy is inverse tan of opposite over adjacent. Notice I'm going to put in positive numbers here, 1429.8 divided by 617. All right, here we go. Second tan, 1429.8 plus, whoops, divided by 617. Did the math correctly all the way to the end, and then 66.7 degrees. There we go. It's 66.658. So 66.7. Ta-da. All right, so what does it say? Left and up. So left and up at 67 degrees with the x-axis. Yeah, that's what we got. All right. So remember that the very first step, take the time to think through which way these electric fields go first, okay? In general, it's toward a negative charge, away from a positive charge. This is the most important thing, okay? This is the most important thing. Nothing is more important than this. If you mess that up, away from positive. So I knew that this guy was away from the positive charge toward the negative charge. So draw that first. Think about that, right? Because you don't want to mess that up and then do all this work based on the wrong angles, okay? And then it's KQ over R squared. Remember that that it's R in general in these things is the square root of what, x squared plus y squared. We're using the distance formula. But in the denominator, it's R squared, and so the square root goes away, right? So it's KQ over R squared. Figure out the magnitude, right? And then think through the angle. Right? Remember that your angles are 0, 90, 180, 270, right? And so in this case, when I went over 3 and up 1 to that guy, right? 3 there and 1 there. Okay. If I want to find this angle here, right? It's going to be this angle here. It's going to be 180 minus whatever that angle is, right? So 180 degrees minus the inverse tan of 1/3. And that's how I do that, right? So just draw a picture of it. Remember 0, 90, and that the trig angle is anti-clockwise from that. If you need to go back and review how to add vectors, there's no shame in that. Okay. Happy hunting.